Hello, all. Welcome back. We are talking about 3-3 today. 3-3 today. All right, we're going to take our Bohr model one more step, and we're going to be talking about Lewis dots on there. All right, but first we must start with our bell work, and our bell work is right here. Hit pause. Meet you down at the bottom. Okie dokie, so 3-3 Lewis dot diagrams. This is page 19. All right, we're just rolling right along. So yesterday we learned, or excuse me, the last time we took notes, whichever, we learned how to do Bohr diagrams. Today we're going to take that a step further and move it into our simplified version, and that's going to be our Lewis dot diagram. Our Lewis dot diagram just signifies our outer or our valence electrons. So let's just jump right into some vocab, and we're going to start right here with Lewis dot diagrams, and this one shows only, that's an in there, oh my goodness, Griffith, too early in the morning apparently, all right, shows only valence electrons. So we're only talking about those outer energy electrons, the ones that are involved in bonding. All right. Now we're on to valence electrons. Remember, these are our outer energy electrons. And these are the ones that are involved in bonding. Okay. So what we're trying to build this up to is we're trying to figure out how many electrons are either going to be transferred or like by either given up or accepted, right? And so we're all trying to get, all of our elements are trying to get to 8 valence electrons. So we're always trying to get to 8 valence electrons, and we can do that by either losing or gaining to get to 8, right? Which if we lose, that means the inner shell or those core electrons now become the valence ones, and they could be 8, or we could talk about 2, but we'll get there in a second. So like I said, trying to get to 8 is what is called the octet rule. So trying to get 8 electrons. So we're all trying to get 8 electrons with the exception of 2 elements, and that is hydrogen and helium, because they can only fit 2 in their outer shell. All right, so this would be they're trying to get 2 electrons in their outer shell. Rolling on, because now we're going to talk about that losing or gaining. So charge tells us electrons lost or gained. Because when we lose electrons, that balance between our protons and electrons, creating a neutral atom, goes away. So now we have an imbalance of protons and electrons, and so we are with a charge. So the first type of charged particle, aka an ion, or a cation, is our cation. Our cation is positively charged. Positively charged means that it has lost electrons, because if you lose electrons, you now have more protons than electrons, which gives us a positive charge. Okay, awesome. The opposite of a cation is an anion. An anion is negatively charged. And so if something is negatively charged, that means we have more electrons than we do protons, which gives us, we have gained electrons. And so now we have that. Okay, awesome. So let's see if we can't put this into practice here. All right. Boop. So let's see. We've got how to write Lewis dot diagrams and find charges. So our first step is we want to find the number of valence electrons. We can either do that via the Bohr model, or we can do that via the electronic configuration. It is up to you. Then we're going to place the dots around the symbol to illustrate the valence electrons, and it's going to be very similar like we did in the Bohr model, where we put them opposite and then double them up if possible. Remember, this is huge, all right? There is never more than 8 electrons around, all right? Never more than 8. Then we'll decide if it becomes easier to lose electrons or gain electrons, all right? And we'll kind of talk about that. And some of them aren't going to lose and gain. That's our noble gases. Remember, that's group 18. All right. Remember, our noble gases are group 18. So if they're in group 18, they're not going to lose or gain, and their charge will be 0 because they're already at 8, or helium is at 2. So let's see what we got. Right here, we're going to start with oxygen. So we can do this two ways. We can either do electron configuration or we can do Bohr diagram. For the first one, I'm going to do electron configuration. For the second one, I'll do the Bohr diagram. So we're going to start with oxygen. Going back to our our electron configurations, we've got 1s2, 2s2, 2p4. All right, so this is oxygen's electron configuration. The valence shell are these biggest numbers, the biggest energy levels, and that's 2. If we add up those electrons, we have 6 electrons. We have 6 valence electrons. So we're going to put oxygen symbol, all right, which is O, and then we're going to put dots around it, and there's 6 of them. So we're going to go opposite, 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 opposite. Then we've got to start doubling them up. All right, and that would be our 6. So oxygen has 6 valence electrons. Take a second, soak that in. Now let's talk about charge. Oxygen has 2 choices, right? Let's change colors here. Oxygen has 2 choices. It could add 2 electrons and become like this, right? Right? And then it would be a full valence shell. Or it could lose 6 electrons. All right? And it would become like this, right? If we lost 6. Which do you think is easier for it to do? To lose 6 or just gain 2? You're right. It gains 2. Now, if we look at that, oxygen started with 8 protons, right? 8 protons. And then we added 2 to it. So now we have 10 electrons. So if we take protons minus electrons, the charge is minus 2. So oxygen's most probable charge is minus 2 because it's going to gain those 2 electrons. Okay? Awesome. Let's try another one. We did sodium in our practice the other day. So let's see if we can't do that right here. We've got sodium, and this time we said we're going to use the Bohr diagram, and this one might make it easier. We'll kind of see. So sodium has 11 protons, 12 neutrons. We're doing it via the Bohr diagram. There we go. There's that. So in the first energy level, we have 2. All right, 2. The second energy level, we can have up to 8, which we need all 8. So we'll put our 8 in there. Remember, opposite, opposite, and then double them up. Okay, so there's our 8. And then in our last energy level, we have, make that a little better, we have just 1. All right, so sodium has that 1 valence electron. Boop, that guy right there, 1 valence electron. So when we put it, we're going to say Na with 1 dot. It could be top, side, bottom. It doesn't really matter. So again, sodium has a couple of choices here. Sodium could gain 7. That feels like a lot. Gain 7 and become this. All right. Or it could lose just 1. All right. And just become this, because then its outer energy level is full. So which is better for it? To lose 1, right? So now if we look at it in terms of this, we've got 11 protons. And we've lost this outer energy level one. So think of the one that's highlighted to be gone. Now we have 10 electrons. We get a +1 charge. And so sodium's probable charge is +1 because it's going to lose just 1 electron. Awesome. See you next time.